Hello, my name's Robert, and our group did Internet of Things, and we are group 13. So a quick overview of our presentation. We split our presentation into three different parts. The first one is the definition, which is what exactly is Internet of Things. Second part is applications, which are like the current applications and future applications. And the third part is the challenges involving IoT. So a quick introduction is I like to introduce it with an example. So an example of something that uses IoT is in cars. Most modern day cars have sophisticated sensors and chips embedded into them, transmitting data into hundreds of cars on the road. This data is then sent to manufacturers' platforms and can be used to make improvements on the car's design, show if the parts on the car need to be fixed, and create applications that solve specific issues. All this data adds up to streamlined inventory management for the car dealer, a better and safer car from the manufacturer, and it gives the driver of the car a more efficient experience. Right, so what exactly is the Internet of Things? According to the International Business Machines Corporations, the Internet of Things is now a reality due to the convergence of several technologies, including wireless communications, microelectrical systems, and of course, the internet. A thing is an object with embedded electronics and can transfer data over a network without any human interaction. Examples are wearable devices, environmental sensories, machinery in factories, devices in homes and buildings, or components in a vehicle. The IoT is a network of physical devices, vehicles, home appliances, and other items embedded within electronics, software, sensors, actuators, and connectivity, which enables these things to connect and exchange data. This data can be used for direct integrations into physical work, resulting in efficiency improvements, economic benefits, and reduced human exertions. To make the definition closer to layman's terms, it's basically wireless communications between devices to make life easier for us. An example would be the grandfather of IoT, the GPS. The main function of the GPS is to pinpoint the user's location and find the most optimal route for their destinations. One of the most popular IoT applications is wearable technology. Currently, we have smartwatches that allow us to see what's our pulse and how many steps we've taken throughout the day, and then send them the data to our phones. Some languages that are developed in IoT are Java, and in Java, developers can create and debug code on their desktop, and then move it to any chip with a Java virtual machine. That means that the code can run not just off servers and smartphones, but also the smallest machines. Another language is C. C is the language of choice for constrained devices. These typically do not include a commercial level operating system, but rather a basic task scheduler type of resource management. C is for programmers who write at the lowest level of software, the ones closest to the hardware. If you are writing for a sensor on bare metal, you are probably using C. The ability to work directly with the RAM makes C one of the first choices for IoT developers. Python. So when small devices have enough memory and computational power, the developers are free to choose the language that makes their life easier. And that language, more often than not, is turning out to be Python. Another language is JavaScript. Much of this work is focused on the servers and gateways or hubs that gather the information and then store it. And then I believe the last language is Swift. So if you want things to interact with an iPhone or iPad, you're probably going to build your app with Swift. So IoT's revenue. By 2020, IoT will be in 95% of electronics for new product designs or 20 billion devices connected to the IoT. And IoT product and service suppliers will generate more than $300 billion in revenue. Glassdoor has an average salary for IoT engineers, developers at $95,000 to $170,000 a year. Some companies in IoT include Amazon, AT&T, Bosch, Dell, and Google.
Hi, I'm Nachelsky Guzman, and I'm going to talk about sensors and the applications of them in IoT. And of course, to gather data, these devices will need different types of sensors. The accelerometer is a good example of a sensor. It detects how fast it's moving. Cars and many other devices, such as your phones, have it. Another is a gyroscope, and this is also integrated with the smartphones, and that's how the devices figure out whether they're upside down or not, and that's how their screens turn and everything. There are plenty of other sensors. You can see them in our daily lives. There are smoke detectors, there are fire detectors. They could alert, and then if there's home invaders, if your doors got open when the alarm is already on, when it gets triggered, the right authorities are going to be called. There's also temperature sensors that is in your thermostat, and there's also the motion sensors that can switch on lights when the movement is detected to save energy. It's used a lot in engineering east buildings, so I'm pretty sure everyone's familiar with that. In cars, we can see sensors such as accelerometer and the proximity sensor. The proximity sensor would most likely be attached at the back of your car, and when it gets too close to something, it will automatically beep or stop the car. As more of these sensors gather data, as the better the computers can predict our preferences throughout our daily lives. So for example, if we once we come back home, the sensors can usually detect what time we come home. We can set computers what time we usually come home, and we can tell the computer to control the AC at what time it should turn on, so it could reach the preferable temperature when we arrive home. So you come home, you get in your door, and there it is. The temperature of your house is at the right temperature. Here are some devices that already have been developed that some people already use in their daily lives. This is the Neuro. Recently Neuro developed an application which is a real-time energy monitoring device. So a lot of us we want to monitor our energy consumption more because we want to save not just bills but our energy consumption. So we want to make sure that we reached a certain peak, and then we would like to not use it as much anymore. And of course, you can't forget about the Amazon Echo that can control your lights, switches, and even thermostats. Another device is developed by Keen Home, and they call it the Smart Vent, which is a room-by-room thermostat control to save the household energy. It can be controlled using the smartphone. It just redirects airflows to the rooms that are not being used. And this one is the ratio. According to Florida's watering department, watering our lawns takes so much, and even for rainy seasons, the sprinklers will come on, even though it's already proven that when it's rainy seasons, you don't really need to water your plants as much. So Rockio developed a smart sprinklers that can just adjust to the seasons and weather and humidity to customize the watering schedule that you can control on your phone. In the past few years, however, home security systems have become much smarter about keeping an eye on your home while you're asleep or out for the day, as well as protecting you better in emergencies. They come in new features and smart technology that old systems can't offer, giving you way more value for your investment. Medical technology. A good example of an IoT device that we use every day that can monitor our heart rate, calorie count, distance traveled, and other medical data is a smartwatch. There are plenty of wearable devices that we see today, and many of them, like the smartwatch, monitors health data gathered from the sensors on the smartwatch and will notify automatically notify our phones if something wrong is detected. Another example is the C3's Clipsulin. It's a device you clip on your insulin injector and detects how much insulin it injected to your body and keeps a time log of your injections and then sends the data to your phone so you can better monitor your insulin. And for future applications, there would be smart cities. An urban area which is a highly advanced in terms of infrastructure, real estate, and or housing facility markets communication and commuting facilities is a city where information technology is high and all essential services are easily available for the residents. In my opinion, the most impressive ongoing project today is the development of smart cities. A smart city is a designation given to that city that incorporates information and community technologies to enhance the quality and performance of urban services, such as energy, transportation, and utilities in order to reduce consumption, wastage, and overall cost. The overarching aim of the smart cities is to enhance the quality of living for its citizens through smart technology. As of now, cities like New York, Yokohama, Barcelona, London, San Francisco, and Amsterdam are already participating to develop their own smart cities.
Hey, I'm Wayne Bailey, and I'm going to be talking about some of the challenges that IoT faces. Okay, so a few challenges that IoT has are security, connectivity, and standards. The hacking of baby monitors, smart fridges, thermostats, drag infusion pumps, cameras, and even the radio in your car are signifying a security nightmare being caused by the future of IoT. To connect all of these devices, we presently rely on the centralized server/client paradigm to authenticate, authorize, and connect different nodes in a network. This model is sufficient for current IoT ecosystems, where tens, hundreds, or even thousands of devices are involved. But when networks grow to join billions and hundreds of billions of devices, centralized systems will turn into a bottleneck. Some technology standards that need to be addressed are network protocols, communication protocols, and data aggression standards. So there must be a driving motivation for starting, investing in, and operating any business. Without a sound and solid business model for IoT, an obstacle will occur where all the requirements for all kinds of e-commerce, vertical markets, horizontal markets, and consumer markets must be satisfied. In reality, business is always a victim of regulatory and legal scrutiny. Uh, Three business categories that can be broken down for IoT are consumer IoT, commercial IoT, and industrial IoT. The challenge of society. Understanding IoT from the customer's regulators perspective is not an easy task for the following reasons. Customer demands and requirements change constantly. New uses for devices as well as new devices sprout and grows at breakneck speeds. And inventing and reintegrating must-have features and capabilities are expensive and take time and resources. IoT creates unique challenges to privacy, many that go beyond the data privacy issues that currently exist. Much of this stems from integrating devices into our environments without us consciously using them. This is becoming more prevalent in consumer devices such as tracking devices for phones and cars, as well as smart televisions. In addition, many IoT scenarios involve device deployments and data collection activities with multinational or global scope that cross social and cultural boundaries. In order to realize the opportunities of the IoT, strategies will need to be developed to respect individual privacy choices across a broad spectrum of expectations, while still fostering innovation in new technologies and services. Okay, so now I'll talk about the milestones of IoT. In 1969, to start things, the first electronic exchange occurred between two computers over ARPANET, the precursor to the internet. Following in 1982, a modified Coke machine at CMU becomes the first internet-connected appliance capable of reporting its inventory. In 1999, Kevin Ashton, co-founder of Auto ID Center at MIT, first coined the phrase Internet of Things in his presentation about radio frequency identification at PG&E. In 2000, a year later, LG releases the world's first connected refrigerator that tracks its contents and alerts when they need to be replenished. 10 years later, Google's self-driving cars hit the road in live tests.
All right, so for a quick summary for our presentation, the Internet of Things involves extending internet connectivity beyond standard devices to any range of traditionally dumb and or non-internet enabled physical devices and everyday objects. There are infinitely many applications and devices that are waiting to be developed, and even though there are many challenges we face as a society, we will eventually overcome and solve these issues and progress forward.
Okay, so here are 5 questions for you guys. 1. What are some languages used by IoT developers? 2. What are some IoT devices that are currently available to us? 3. What are some IoT development ideas in the future? 4. What are some challenges IoT developers face today? And lastly, what are some milestones that we've already accomplished?